This is gonna be another one of those worksheets where Quagsire goes more specifically into the vocabulary. But I'm gonna go over the general idea and the basic gist of what the worksheets are saying and what the worksheets are basically arguing for, um, as far as what they're basically saying. This is the crux of the whole unit. Like the first part of the unit, we went over triangles and all the different things we knew about triangles, all their different properties, all the different types of triangles, how we can classify triangles with the isosceles, the equilateral, etc., with the scaling, acute, obtuse, all that other good stuff. All that classification and all those different relationships, that's all well and good. But the thrust of this unit is called triangles and congruencies. And so the second part of that unit is what we're going to start today, the congruency part. So what does it mean to have a congruent triangle? If two triangles are congruent, then it means that it means that every side is the same length, and it means that every angle is the same measurement. Now, the question is, does that mean that they are equal? Um, Technically, no. Um, and this is where folks start to learn to learn to dislike geometry again, because as far as geometry is concerned, if something is equal, then it is the same object. If something is congruent, then it is an identical copy of the same object. And so if something is an identical copy of the same object, not then it's said to be congruent. If it is a proportionate copy of the same object, it is said to be similar. All of Unit 4 was about similarity, about how if you have a scale factor, a uniform scale factor that can take all of the sides from one triangle or one shape, you apply that scale factor, and now the shape is bigger or smaller, just kind of like the transformation dilation, and the angles stay the same, but the sides are a little bit longer, but they're all still proportional relative to that original image, then those shapes are similar, but they're not congruent. Congruent means that if you have side A equals 5, that you have another triangle that side A equals 5, side B equals 3, second side B equals 3, side C equals 6, third side equals 6. So all of the sides have to be equal, all of the angles have to be equal. You basically have to be able to pick up the second triangle, flip it, rotate it, alter it, do whatever you need to change its position, but not its overall shape and not its proportions, and be able to place it over the top of another over the, I don't want to say original because that implies that you're holding the copy, but place it on top of its congruent partner and have a perfect overlay of one on top of the other. So that's what congruency is. And so if you have congruent triangles, looking at the worksheet here, a congruent statement basically means that it's like a similarity statement. With the similarity statement, we had like triangle ABC is similar to triangle DEF. The similarity statement was like one little tilde. It was one little black. It was like one little black wavy line, and that was what similarity stood for. It was proportionately speaking. Now it wasn't the same object, but proportionally speaking, you could treat it like the same object. Congruency statement, you can see that it's still got the same little tilde there, but it's also got an equal sign. And that's kind of the extra dimension that tells you that it's a higher order of equality than just the similarity. And so when you're doing a congruency statement, If the triangles are congruent, you write the congruency statement, and it's all the same rules as with the similarity statement, where the order has to matter, where the order absolutely matters. Where if you're going to say angle A, we're going to say angle ABC is congruent to angle DEF, excuse me. Where if you're going to say triangle ABC is congruent to triangle DEF, then you're saying that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. For the most part, especially as far as similarity is concerned, nobody's really had that big of an issue with it as far as remembering it for the assessments and remembering it for some of the math issues. Writing the similarity statements is a bit of a different story, but we can work on that. And so if you know that two triangles are congruent, then you know a piece of information about that about a triangle, then you know that same information about the other triangle. Like before, if you knew about a similar shape, like if you knew about like if you had two triangles that were similar, you knew hopefully that the angles were equal. You knew that whatever the angle measurements were, they would be 100% equal. You also knew that the sides would be proportional, and that the sides would be proportional, and that well, they would either be proportional or they would scale up or down based on a constant scale factor that applied to all of the sides. And so you knew that just by virtue of the fact that the two shapes were similar. In this case, if they are congruent, you know that the two sides are the same length. You know that the two angles are the same measurement. And not only that, you know that the other two sides are going to be the same as those other two sides. And those other two angles are going to be the same as the other two angles. You know that they are more or less going to be an exact copy of each other. And so that's what it means about being congruent. And so you're going to get a couple of different concepts about congruent parts, about congruent triangles, the idea about corresponding parts being equal, etc. But what it means is that if you know that two shapes are congruent to one another, it's another means of problem solving. It's another way of solving problems with triangles, another way of solving problems with shapes, because congruency doesn't just apply to triangles, it can apply to all other kinds of shapes. Um, so it, and so, yeah, so there's, I guess there's that. Now the train of thought decides to derail. But yeah, it's another means, it's another set of resources for problem solving that allow you to, that allow you to, yeah, train of thought was effectively derailed. It's another set of tools that allow you to solve a different set of problems that you're gonna be facing. And so we understand, first of all, what the nature of the triangles are. We understand some of their characteristics. We understand what makes them, what makes certain triangles equal, what makes certain triangle angles equal, what the characteristics of equilateral triangles are. And with a few algebraic tricks, we understand how to calculate missing sides or angles or all that other good stuff that we've been doing the last couple of days. But now we're moving into congruency, and now we're moving into the part of triangles and the characteristics of triangles where if you know that they are congruent, or if you can prove they are congruent, that is, now you're doing something really powerful. Now you're able to do something really, really significant, at least as far as geometry is concerned. So again, the first front part of the worksheet, I'm going to have Quagsire help you fill in most of that with the vocabulary. What I did was kind of the 10,000 miles up overview of everything. This video is going to give the, like I said, it's going to be the overview, and then we're just going to go into the math of it. Let's see. Those are relationship statements. Okay, yeah. We're going to go into the math of it here, and we're going to start solving some problems, and yeah, here we go. So the back page of it is all math. The front part of it is going to be relationships. Like I said, that Quagsire is going to help you out with. So yeah, there we go. All right, let's get started. So we're given to start out with that these two are congruent to each other. And just like with the similarity statements, what I would honestly recommend is if you know they're congruent to each other, just mark out the angles. So I know that S is congruent to B, T is going to be congruent to F, and then W is going to be congruent to N. So now I know that the length. So now I know that the length between so S and W is the length between S and W is 9 centimeters, and that's the length between reference angle 1 and 3. Well, between reference angle 1 and 3 here, now I know that's 9 centimeters. I know that angle N, I know that angle reference 3 is 82 degrees. So this is 82 degrees. I know that between reference angle 1 and 2, that's 17 meters. Between reference angle 1 and 2, that's 17 meters. Now let's see what else can I learn here. Oh, here we go. I was apparently supposed to write it over here. So let's get started. BN, I know that's supposed to be 9 centimeters. All right. TW, let's see. What's the between? Here we are. TW. So the length between reference angles 2 and 3 on this triangle are 14. Well, they're congruent, so that means that between reference angles 2 and 3 over here, they're 14. All right. So I've got BF. That's the space between reference angles 1 and 2. Well, I got reference angles 1 and 2. That's 17. I already solved that one. And then let's see, measure of angle W. I already solved that one. That's that's angle reference 3, and W is angle reference 3, so that's 82 degrees. Measure of angle B, that one is, let's see. Oh, well, this one's actually a little bit trickier. Measure of angle B. Well, what I'm going to do is I'm going to solve for T. So I've got over here, I've got 82 and 67. So 180 minus 82 minus 67 equals 31. So this one's 31, which means this one's 31, and this one's 67. All right, well, so measure of angle B is 67, and then the measure of angle F is going to be 31. I guess I was planning on using the supplementary theorem, the 180 degree measurement theorem, but then I forgot that they're congruent, and as soon as I solve something with one of these, I solve it with the other. So yeah, there we go. All right, so here we are, given that these are similar, given that these are congruent, find each missing measure. So these are isosceles triangles, so we already know a bunch of stuff about them, but let's see what else we can find out just based on the fact that they're congruent. So again, I'm going to mark out the angles and the angle references. So G is to X as H, and H is to Y, and then J is to Z. There we go, that's 3. Let's see, let's start with GJ. GJ is the base between reference angles 1 and 3, so that's 18. That's 27. XY is, well, all of these are going to equal 27 because because both of these are isosceles triangles, and because they're congruent. If this is 27, then this is 27, and because they're isosceles, they're congruent. So yeah, they're all 27. XY is 27. ZY is 27. Okay, now we're moving on to the angles. All right. So measure of angle H is that's going to be 38. And then measure of angle Z and J. That one I'm going to use my old isosceles, use the trick that I used with isosceles triangles, which is I'm going to take 180 minus 38. That's going to give me 142 divided by 2 is 71. I'm just going to write 71 twice because z and j are going to be equal to each other. Oh, well, because z and j are each other. I thought that they were going to be, yeah, all right. Yeah, because they're congruent parts, they are equal to they are each other. So yeah. So yep, yep. It's going to take a little bit of getting used to. It's going to take a little bit of yeah. So now we're going to start doing some algebra, but this is kind of where the congruence. This is kind of where congruence is really going to start paying off. First things first, with the congruent statements, especially now that we're not given points or sides or anything like that. Now really we have to start marking the reference side. So U is to T, V is to S, and then W is to R. All right. So let's start with this. We'll start with X. The length between 1 and 2. Do I have anything? Yep. 12x minus 7 equals 53. So 12x equals 60, x equals 5. So there's the first one, just right off the bat. Sweet. Let's see if I can figure out why. Yeah, between reference angles 2 and 3, over here is 57. Between 2 and 3 is 5y. So yeah, 5y minus 33 equals 57. So 5y equals 80, 90. Y equals 90 divided by 5, 18. There we go. All right, now Z, I think that one's going to be a little bit trickier. Oh, wait, where is Z? I think between 1 and 3. Oh, all right. Just kind of shaking things up here, but all right. It's between 1 and 3, so yeah, I was just kind of staring at it for a while. Maybe I have been filming a little too long. So I've got 3z plus 14 equals 50. So that's 3z plus 14 equals 50. And that's going to be 3z equals 40, 36. Z equals 12. So again, it's not like when we were doing similarity statements where we had to worry about scaling things up and down properly. With congruencies, it's just there. We just have it. It's just equal. And so that's how we solve for it. It's a higher order of equality, if you want to call it that. So, all right. Next one, we have PHS, C and F. So again, P is to C, H, probably a little bit more intuitive than this one, is N, and then S is to F. Okay. Again, like I said, if we know they're congruent, then we know they're basically equal. And some of the shapes of the triangles are going to be intuitive, but like if you look at this one up here, it was rotated and flipped. So again, use the congruency statements to mark the reference points, just to kind of keep things going. So we'll get started. So again, find the values of x, y, and z. Now let's start with x. So x is attached to this obtuse angle, which is equal to 115. All right, so 6x minus 29 equals 115. 6x equals 115 plus 29 equals 144. Divided by 6 equals 24. X equals 24. That was a good show. Next, let's solve for y. 3y minus 1 equals, and I'm looking for the 3. Okay. Let's see here. Oh, well, this is 115. Excuse me. Okay, all right, I know what I can do. So 180 minus 115 minus 36 equals, so this is 29. And so for y, with y is part of reference angle 3, and reference angle 3 over here is 29. So 3y minus 1 equals 29. Y equals 30, 3y equals 30, y equals 10. There we go. So that's y. And now z, I can see z is next to reference angle 1, which is equal to 36. So 4z minus 32 equals 36. All right. So 4z equals 36 plus 32 is 68. 68 divided by 4 equals 17. So z equals 17. I mean, compared to some of the other similarity problems, and compared to the angle relationship problems, and definitely compared to the transformation problems, you don't even need to know some of the triangle identities. They definitely help. But this is just, you're basically working with the same triangle. It's just that you're getting information about it at different times. And so, yeah, I mean, this is just so much easier and so much faster than similar triangles. Um, and that's basically that's one of the properties of congruent shapes and congruent triangles. So, um, yeah, this is the good stuff. This is the good stuff here. So let's see. Triangles DEF are congruent to JKL. All right. Let's see. This isn't going to be the scale, but I've got D, E, F, and then I'm just going to do this J, K, L, and then D is J, E is going to be K, and then F is going to be L. I don't know anything about either of these two triangles. I just know what they're named and what their reference angles are. So DE equals 18. So that means JK equals 18. EF equals 23. So that means KL equals 23. And DF equals 9x minus 23. So that equals 9x minus 23. JL equals, so DF equals 9x minus 23. JL equals 7x minus 11. And JK, equals 3y minus 21. 3y minus 21. Got a little ahead of myself there. So I have to find the values of x and y. I got a little ahead of myself there. So let's see. This one's going to be a little bit more complicated, but still, the process is going to be pretty familiar. So 9x minus 23 equals 7x minus 11. Again, if you just have something like 7x minus 11, it's completely meaningless. It's completely useless. There's nothing you can do with it. But if you say 7x minus 11 equals anything, even if it just equals another x, now you've got something. Now you've got something you can work with. And so, so I'm going to subtract 7x from both sides. That's going to give me 2x. Then I'm going to then I'm going to add 23 to negative 11. That's going to give you 2x equals 12. So x equals 6. So I'm just asked for the values of x and y. So now I just have to solve for y. Yep. 3y minus 21 equals 18. Like I said, I got a little ahead of myself filling in the values for the other triangles because, again, I knew if these were the congruent parts that this was what they were going to equal. So 3y equals 39. Y equals, I think I already did this one, 39 divided by 3 equals 13, yeah. So there we go, y equals 13. The delay for this problem was that I had too much information to act on that I still ended up using. So yeah, this is so much better than similarity. All right, so QRS and MNP, they are congruent. So again, this is not to scale. This is just to um, get things orderly. So M and then R and then to N and then S into P. All right. QR equals 11. All righty. QS is 15. Obviously not to scale. MP is 2x plus 1. Measure of angle S is 84. Measure of angle R is 32. And measure of angle M is 17y minus 4. Find the values of x and y. All right. Well, I'll start with x because that's the easiest one. 2x plus 1 equals 15. I mean, it's the side with the reference between the reference angles 1 and 3, and I've got a value for that between the reference angles 1 and 3, so it's 15. So 2x plus 1 is 15. It means that 2x equals 14, so x equals 7. I mean, I'm not even doing complex algebra. I mean, I understand that I'm doing a lot of this very quickly, but it's, again, not very complex, so I can do it quickly. This one is going to take a little bit more work. So angle Q, for example, because they're congruent, we know that angle Q is going to equal angle M. So as soon as I find angle Q, I'm going to have angle M. So basically what I'm going to do is 180 minus 32 minus 84. That's going to give me 64. So 17y minus 4 equals 64. Because Q and M are equal to one another. And if this is, so that means that this is 64, this is 64. So 17y minus 4 equals 64. So that means 17y equals 68. So 68 divided by 17, probably 4. Y equals 4. And there we go. That is how we use congruency to solve triangle problems. I love that. I love that phrase. I even named a lesson after it. Triangle problems. Let's see. So coming up next, we have stage 1. We have one review. Yep, and then we are going to have a second review of my design, which is going to get you completely. So we have one review that's going to get you prepped for my review. That's going to get you prepped for the first assessment. Main reason being that it's just the way that the schedule works out. You leave for Thanksgiving break on a Tuesday, and so the assessment is going to be on Tuesday, and so my review is going to be on a Monday. So there we go. Yeah, I'll see you then.